here we're faced with the following question. It is very easy to get scared of this question very quickly, I'll tell you this. But it is not as scary as you might think. Let's take things step by step. So to start, I think we can agree that this is really the beast here. This is the beast of our problem. So let's try to make progress as much as we can without really, looking at what this thing is. So we have a cross product of two terms. Here's how it should go. As follows. So I have this nice setup on the side to refresh. The cross product is computed by computing the determinant. Replace u with these values, replace v with these values. And I set on to use one of the rows. In the case of the cross product, you should always use the first row, the one that has the unit vectors, to break this determinant down into smaller vectors. It would look something like this. I here with a smaller determinant, j here with a smaller determinant, and k here with a smaller determinant. Now notice that I've still not added things here. These are supposed to be signs. How do I determine the sign of each component? Well, I use this map, you could say, to identify this. So I is in the upper left side of this map, so it should be positive. And j is next to it, it should be negative. K is there, it should be positive. So this should be straightforward at least. I have this, and now I still need to write down my smaller matrices. If I do this quickly, I make two lines, one in the row and one in the column of the element which I want to find the corresponding determinant for. So here for I do this, and I see I have these two. So I'll do a very nice thing. I'll copy them as they are. This would require a little bit more space. Which is possible, I think. Yeah, I do the same thing for j. I get u1, u3, v1, v3. And I do this one more time for k. And I get u1, u2, v1, v2. And I can take this even one step further. So the way we compute the matrix is we multiply this by that minus this times that. So I would actually get I u2 v3 minus v2 u3. So I do the same thing for j. I get u1 v3 minus v1 u3. Well, this is a minus sign, do not forget. And I do this for k now. u1 v2 minus U2 V1. So we're getting very, very close. Finally, I can even take this even one more step further, and I can write it in a more compact form, which is the form of a vector. But that is just a matter of taste. So this is the first coordinate I. This is almost second coordinate j, because there's a minus. And finally, there is the coefficient of k, which is this. Now, if I take the minus of this, then I just get minus of this plus that. I hope you don't mind if I just, switch them around. So this is the minus part, this is the positive part. And this should be okay. And I don't really think we can make any further progress on this problem while ignoring this epsilon. And so I have some ideas. Let me try to link it somehow to the values we have here. Before I do that, please give me a moment. I would like to switch this U for that V, since all of them are ordered, UV, UV, UV. I think this is, it's very nice to be consistent in that sense. Next, I want to make an observation about this. So if we just take a moment to look at this, I don't think it is too difficult to see that it talks about symbols. Symbols. So here we have a positive symbol. And if we take a look here, we have a negative symbol. Perhaps we could link these numbers to these constants somehow. I'm not too sure. First off, let's circle back to what we were looking to find in the first place. We're looking to find an expression, a way to express kth component of this cross product. This is the first component. And this is the second one, and this is the third one. I want you to notice that here I have ijk. So this could be hinting at something. ijk. Well, let's see. So, 2, 3, 1. 2, 3, 1. Okay. 3, 2, 1. So 3, 2. Maybe I'll just use a different color for this 1, because it's not really meaningful if I do this. But I'm trying to show you the link now. Same thing here. 3, 1, 2. But at the same time, 1, 3, 2. I'm running out of colors. And then finally, I do this one more time. So I get 1, 2, 3. 1, 2, 3. And for the red part, it's 2, 1, 3. 2, 1, 3. And now I find the third color for this. this is horrible. No, don't let me use that. I use the brown maybe. Maybe the brown is nice enough for me to use it. Okay, so it looks like we can determine the sign just by looking at the indices. So I can write something of this sort. I can write something of UIVJ and I would be talking about multiplying this by some epsilon ijk, and then let's say I sum this up over all indices I and also all indices j. Now let me write all the 9 indices that we'll have. We will have 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, and now finally 3 1, 3 2, and 3 3. So this is just an example. Let's say that, for the sake of this discussion, we're looking at so we're looking at the kth component. So I would like to give myself a little bit more space here. Let me do that. Much more space. Amazing. So I do like this, and I say, okay, this is going to be the kth component of u times v. I do this, and we would like to take a good look at why this actually works now. So if this is a sum of sums, I will get 9 possibilities because this loop is fixed. It's a loop inside of a loop. If you're a computer scientist, you know what this means, of course. So I get these 9 possibilities. You can convince yourself by this if you write down all the terms and expand. Now let's see which ones are going to be 1, which ones are going to be minus 1, and which ones are going to be 0 when I have k is equal to 1. So let's say I'm looking at the first term in this u times v. So if k is equal to 1, I'll get 1, 1, 1. So 1 with 1, 1, 1, 1. I'll always put the k at the end. I'll always put the k at the end. 1, 1, 1, 1, 2, 1, 1, 2, 1. So 1, 1, 1 is 0 because it's in else, it's not anywhere here. 1, 2, 1 is 0. And 1, 3, 1 is 0. 2, 2, 1 is 0. This is also 0. This is 0. And this is also 0. So these are the only non-zero terms. This term will be positive. I should color it. Will be positive, and the other term will be negative. You could play this game, by the way. I would like you to play this game with k is equal to 2 and k is equal to 3, just to make sure you really understood what's going on here. I think this will be a really good exercise for you. Try to write all the indices, see which ones cancel out. And then you can convince yourself, of course, that you've already understood the assignment. And if we're able to do this, then this is very powerful in my opinion, because we don't really need to think. We have a formula that computes everything for us. So you should check which indices cancel, which indices are positive and which indices are negative. You should always get 7 indices which cancel out, and one that's positive, one that's negative, just like we saw here. And make sure they'll be identical to the ones that we've unraveled. So precisely the ones that are in the expression here. Check this. This is correct, then amazing. You have a formula to describe what's going on. And if there's something to take away from this exercise, it is to try to work with what you have and what you know, and to not be afraid to at least make partial progress, even if you don't see, the final step they need to do. Even if the road is not clear, that doesn't mean that you should give up and not continue trying to, carve your path forward. This is very important, not just for this question, and not just for the exam that you'll take. I think it is useful for your academic career and perhaps even your personal future endeavors. So I hope this was a great help, and this is it.